Welcome to 3.3 Completing the Square, Part 1. What you'll learn is to solve quadratic equations using square roots, solve quadratic equations by completing the square, and write quadratic functions in vertex form. So previously, we've solved equations in the form of some value squared equals d by taking the square root of each side. This method also works when one side of an equation is a perfect square trinomial and the other side is a constant. So let's take a look. So example 1, solve x squared minus 16x plus 64 equals 100. Now, the goal here is to get something squared equals some number. That's the goal, okay? This is the goal. And we can factor or create a factor out of x squared minus 16x plus 64 to where it is the two binomials are the same. So let's just show you, okay? Be easier to show you. So x squared, remember how I factor. So x squared is x times x. 64 is negative 8 times negative 8. And when you cross multiply, you get negative 8x. Negative 8x equals negative 16x. That is your middle term, okay? So your factors are straight across. It is x minus 8, x minus 8. It equals 100. And then you can actually write that because those are the same factor twice, the same binomials, x minus 8 squared. We talked about this when we were factoring, and we're going to actually use this little phenomenon, okay? And then we can solve this back like we did in section 1. We can take the square root of both sides. Don't forget about your positive and negative. So that leaves us with x minus 8 equals positive negative, and the square root of 100 is 10. We're going to add 8 to both sides. So we get x equals 8 plus or minus 10. We're going to break it into two parts. So x equals 8 plus 10, and x equals 8 minus 10. So x equals 18, x equals negative 2. So we get two solutions here. Okay? Now, I want to point out this, this special case where when we factor our polynomial up here, our quadratic equation, and we get the same two factors, okay, same two binomials, and then we can write them as x minus x plus or minus a number squared. This is the ultimate goal, is to write it this way and to have this special characteristic come out. If we can do this, solving this becomes, it's just another way we can solve quadratic equations, and this is called completing the square. So let's take a look. All right, so to complete the square for the expression x squared plus bx, add b over 2 squared. Now that is the key. That is very important. So you need to know that, keep that close by, okay? For us to guarantee that this part here can be factored like this, like something squared, we need to make sure that this is a perfect square trinomial. That means that I can factor this and use these two same binomials, okay? And it ends up factoring this way. So we're going to force this to happen, all right? And the way we force this to happen is that we want our c value to be this, whatever this is. So you take your middle term, you divide it by 2, and you square it, all right? So in each diagram, the combined area of the shaded region, x squared plus bx. So this is a picture version of this same concept. A lot of algebra teachers, they use the area model when they talk about factoring. We did not, to review that, we did not. We just went straight to the algebraic methods. But this is the area model. Notice you have x, and this is the b we know of. There's your b, there's your b. We know we're going to have x times x, and we got to figure out what this we need here, okay? So that's the idea behind it. It's a picture version. And algebraically, we take b over 2 squared, and it factors x plus b over 2, x plus b over 2, and we can factor that, or simplify that as x plus b over 2 squared. All right, this is a little bit more complicated, but it's really easy when we start looking at it with numbers, okay? So the big thing is, remember, b over 2 squared is the ideal c value, okay? So let's take a look. Let's factor example 2. Let's find c. Find the value c that makes x squared plus 14x plus c a perfect square trinomial. Then write the expression as a square of a binomial. So we've got to find that perfect value. So we're going to practice that first before we go into solving. So you take your b value, it's b over 2, and you're going to square it. Okay, so our b value here is 14. Take it, divide it by 2, and we're going to square it. So that's 7 squared, which is 49. So 49 is that magic c value that's going to make it possible for us to write this as a perfect square trinomial. So let's do that. And I'm going to walk you through factoring it. There is a shortcut, and I will show you that after we factor, okay? So x squared is x times x. 49 is 7 times 7. Check our cross products. That is 14x. So we can factor this as x plus 7, or we can write this as x plus 7 squared, okay? This is the footwork behind it, but really, since we force this c value to be a perfect square trinomial, we can bring this number right here, if we say x plus whatever value that is, and square it will be that in the factored form, because we forced it to be that way. All right, and what they're saying is that we take b over 2. b over 2 is 14 over 2, which is 7. We take that number before we square it, and that's our x plus or minus that number. That's a special number. Okay, so let's look at example 3. So we're actually going to use this. I'll show you where it's going to be useful. All right, so we have x squared minus 10x plus 7 equals 0. Now here's the key. Always take the c and get rid of it, move it to the other side. It's 100%, it's not really necessary, but visually it helps out, okay? So minus 10x, leave room for your c value, equals negative 7. All right, so let's figure out our c value here. Let's figure out c. So we're going to take our b over 2, and you're going to square it. So our b value here is negative 10. Divide it by 2, and you square it. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25. 25 is the number we're going to add to both sides. So plus 25 plus 25. Because it's still an equation, what we do to one side, we have to do the other. Okay? Now we're going to factor the left-hand side. This is going to factor every time, like we'll have an x as the first term, and the number before it was squared, let's take a look over here. Let's use a highlighter. This number right here, before you square it, is your second value. It's minus 5. Minus 5 squared equals negative 7 plus 25 is 18. And now we can solve. So we have it in a format we can solve. So we're going to take the square root of both sides. Don't forget about your plus and minus. So we get x minus 5 is equal positive negative square root of 18. We're going to add 5. So x equals 5 plus or minus the square root of 18. The square root of 18 does simplify, so we can keep on going a little bit. 18 is 9 times 2. And the square root of 9 is 3. So we can bring that out of the radical. So plus or minus 3 square root of 2. Now that means 5 plus the 3 square root of 2 and 5 minus 3 square root of 2. But we can leave it as one sentence, but you have to remember that is 2 solutions there. Okay? And that is solving by using, by completing the square. Just another way we can do that. Okay? Let's do one more example just to be on the safe side. All right, so we have x squared plus 8x minus 5 is equal to 0. For those who use the guided notes, this is not in the guided notes, so you may want to write to the side, okay? All right, so do the process again. Move your C value, your current C value, over to the right. That leaves you with x squared plus 8x, leave room for C, and 0 plus 5 is 5. Now we're going to find our ideal C, our perfect C that makes this a perfect square trinomial, okay? So we're going to take our 8, divide it by 2, and square it. So that's 4 squared, or 16. So we're going to add 16 to both sides. What you do to one side, you have to do to the other. Now we force the left-hand side to be a perfect square trinomial. So if you don't believe me, you can still go through the factoring process, but this is going to be x, and since your middle term was positive, it's going to be plus, and you also know before you squared it, it was also a positive 4, so it's going to be 4. So 4 squared, the whole thing squared, because it's x plus 4 times x plus 4, equals 21. Now we're ready to solve it. We have x listed once. It's gonna be just the same process. So you're gonna take the square root of both sides. Don't forget about your positive and negative values on the right-hand side. So it leaves us with x plus 4 equals positive negative square root of 21. Then we're going to subtract 4 from both sides. So x equals negative 4 plus or minus the square root of 21. Now, can 21 be simplified? Well, 21 is just 7 times 3, no pairs, so that cannot be simplified. So that is the best we have. And remember, that's two answers. That's negative 4 plus 21 and negative 4 minus 21. So those are your two answers there. Okay, that's all we're going to do today. We're going to save the rest for tomorrow. All right, you guys have a great day, and good luck with your assignment.